Yes, whatever you say goes on the recording. So the first question gives us the integral of f of x from a to b, and we're asked to find the integral of f of x plus 2. So any integral, when you're adding within the integrand, you can split it up into two different integrals. So this integral equals the integral of f of x plus the integral of 2. Now, the first integral, which is from a to b, we know that it equals 10 because that's what we're given in the question. And then the second integral, we first need to integrate 2 and then do the limits of integration. So the integral of 2 is 2x, and then we will be figuring out what that is from b to a. And so we first plug in b, which is the upper limit of integration, and then subtract the lower limit of integration, plugging that in, which is 2a. And so the answer is going to be 10 plus 2b minus 2a.
Put a space here. This is 10 in class.
Next question, we are asked to integrate based on the figure that we're given. So the first integral, we can probably zoom in quite a bit here. We want to find the integral from 3 to 10. And so that means that we need to calculate this area here, 3 to 10. Okay? And so we can split this up into different shapes. So maybe we can call this area 1, area 2, and area 3. And so the area of area 1 from 3 to 4 is a rectangle which has width 1 and height 2. So the area is going to be 2. The area of region 2, we have a height 2 and width 2, but it's a triangle. And so that means that we're going to do 1/2 times 2 times 2, which is 2. And then the area of region 3, we have a triangle once again, but now the width of the triangle is 4, right? 6 to 10, and the height is 2. However, it's also negative, right? Because this is an area that's below the x-axis. And so the area here is going to be -4. Okay, so that means that the integral from 3 to 10 is going to be 2 plus 2 minus 4, which is 0. All right, if we're asked now to find the integral from 0 to 6, that means that we need to also include 2 other regions, right? We're going to be looking also at region 4 here and region 5. So what is the area of region 4? That is a triangle with width 1 and height 1. So that's 1/2 times 1 times 1. But it's also negative, right? Because it's below the x-axis. And so that has an area of -1/2. Now for area 5, this is also a triangle. So it's 1/2 times 2 times 2, which is 2. Okay. And so the area from 0 to 6 is going to be the combination of 4, 5, 1, and 2. And so that's -1/2 plus 2 plus 2 plus 2, which is equal to -11/12. So that's 2, and this is -11/12. Sorry, it's positive 11/12, not negative. Question 3. find the general solution of the differential equation, and then check your answer by differentiating. So if we're given the derivative, which is 5 sine plus 3 cosine, that means to find the original function, g, we need to integrate the derivative. So g of y is equal to the integral of dg dy, which is equal to the integral of 5 sine y plus 3 cosine y dy. And then to integrate that, we need to think about what's the integral of sine. That is going to be negative cosine. So we'll have negative 5 cosine y plus 3 sine y. And then we have to have a plus c because this is an indefinite integral. All right, so remember that the integral of sine is not cosine, but negative cosine. And then we can check all this by differentiating g once again. So if we differentiate our answer here, we should get our original derivative. And indeed, the derivative of negative 5 cosine y is 5 sine y, because the derivative of cosine is negative sine. And then the derivative of 3 sine y is 3 cosine y. So we can confirm that indeed we have the correct indefinite integral. Next question, we're asked to evaluate this definite integral. So first we need to calculate the indefinite integral. And so if we anti-differentiate, we're going to be getting x squared, right? 2x becomes x squared because we raise x to a power of 2 and divide by that power. So 2 divided by 2 times x squared. And then the integral of cosine x is sine x. You can just think about what gives you a derivative of cosine x. And then we're going to evaluate this between 0 and pi. And so that means we have to first plug in the upper limit and then plug in the lower limit and then subtract the two. Okay, so that means that to calculate the definite integral here, we're going to have pi squared plus sine pi minus 0 squared plus sine 0. Now sine pi is 0. You should know your unit circle well by now. And we're going to subtract 0, and sine 0 is also 0. And so the answer is pi squared. Fifth question, we're looking at Riemann sums here. And we're looking at this function along this closed interval. So let me draw it out. It's always very helpful to draw the function on the graph first. We're looking at the interval from -3 to 7. So we're given the value of the function at 5 points at 0, 2, and also 5. And let's see. The function at -3 is -5. So that's here. Function at 0 is 0. Function at 2 is 5. And the function at 5 is 10. And the function at 7 is 13. And so if we connect this, the function is going to look like that, right? So let's look at the heights now. So the height of this function at -3, it's below the x-axis, so that's a negative height. It's a height -5. Height at 0 is 0. Height at 2 is, what is it? It's 5. The height at 5 is 10. And the height at 7 is 13. Okay, so we can first calculate the right Riemann sum. That means that we're going to be looking at this rectangle. The first rectangle is just going to be a flat line because there's no height at all. We're looking at the height of 0. And then the second rectangle is 0 to 5. 0 to 2, sorry. Height 5. And this is the third rectangle, and this is the fourth rectangle. And so that means that the total area is going to be 0 times, so 3 times 0 plus 2 times 5 That's the width times height of the second rectangle. And 3 times 10 for the next one. Plus 2 times 13 for the last one. And that is going to give us 10 plus 30 plus 26, which is 66. All right, how about the left Riemann sum? Well, for the left Riemann sum,
You should open our real time. This one.
for the left Riemann sum, we are going to be looking at the rectangles now defined with heights by the left side of the integral. So we're looking at these rectangles now. So for all these rectangles, the height is defined by the left side of the interval. And so this height is -5, this height is 0, this height is 5, and this height here is 10. Let's also look at the widths. We have a width of 3, a width of 2, a width of 3, and a width of 2. And so the total area is 3 times -5 plus 2 times 0 plus 3 times 5 plus 2 times 10, which is equal to 20. Okay, so that's the left Riemann sum. And as I told you guys in class, the trapezoidal approximation is just going to be the area of the left and right Riemann sums. So that's 1/2 times 20, sorry, 1/2 times 20 plus 66, which is 43. Question 5.
What are you doing?
We're trying to evaluate the integral of 5 cosecant squared. And so we're going to think about which trig function gives us a derivative of cosecant squared. Well, we know that the derivative of cotangent squared,
Why are they actually?
sorry, we know that the derivative of cotangent x is equal to negative cosecant squared. That's something we should know by memory. And so that means that the integral of 5 cosecant squared x is going to be -5 cotangent x. Right? If the derivative of cotangent is negative cosecant squared, then the integral of cosecant squared should be negative cotangent, and then the 5 stays there. And we also need a plus c. If there's no plus c, that's a small amount of points off. Next question, we're trying to evaluate this. To do this, we should split this up first into powers, additions of powers. So the derivative, which is the square root of x, that's just x to the 1/2. And so x squared divided by x to the 1/2 is x to the 3/2, plus 3 times x divided by x to the 1/2, which is x to the 1/2. And so now we just need to integrate these. So we're going to look at the power of the first one, 3/2, add 1, and then take the reciprocal of that. So 3/2 plus 1 is 5/2, and then the reciprocal is 2/5. So we have 2/5 x to the 5/2. Then the 1/2 plus 1 is 3/2. So we should have 3 times the reciprocal of 3/2, which is 2/3. 3 times 2/3 x to the 3/2, and plus c at the end. So if we simplify this, we'll get 2/5 x to the 5/2 plus 2x to the 3/2 plus c. Next question, we're given a few definite integrals and we're asked to find some other definite integrals as well. So here we have to use some tricks or using some of the identities that we learned in class. So for this one, the first one, we should first use the fact that the integral from -3 to 7 is equal to the integral of -3 to 0 plus the integral of 0 to 7, right? Logically speaking, right, the area is just going to be -3 to 0 plus this area from 0 to 7. And that should equal the total area from -3 to 7. Okay, so that just tells us that 3 equals, oh, sorry, there's a typo. I didn't give you guys the value of this integral here. Let's just say this is equal to -2. Okay, I'll make that adjustment to the question. So the integral of -3 to 7 is equal to the integral of -3 to 0 plus the integral of 0 to 7. And so that means that 3 equals -2 plus the integral of 0 to 7. And so that means that the integral of 0 to 7 f of x dx is equal to 5. The next one, we just need to use the fact that the integral of 7 to 0 is equal to the negative of the integral of 0 to 7. And that is because when we evaluate the integral from right to left, that's the negative of as when we evaluate from left to right. And so this is just going to be -5. For part C, this is just going to be equal to 0, and we can know that just from looking at it, because the upper and lower limits of integration are the same. And so that means we're just evaluating the area under a curve, but the width is equal to 0. And so the area is obviously 0. And then for the last one, this integral is equal to the negative of the integral from -3 to 0, which we know is -2. And so this should equal +2. Next question, evaluate the integral from -pi/2 to pi. And so for this question here, we should first evaluate the indefinite integral. So the indefinite integral of sine u minus cosine u is negative cosine u plus sine u it's not correct. It's negative cosine u minus sine u. And we're evaluating this from -pi/2 to pi. So make sure you're not getting the signs confused. If you're ever worried, you can always differentiate what you're finding here, and you just want to confirm that you're going to get this. So the derivative of negative cosine is positive sine, and the derivative of negative sine is negative cosine, and so that means we're good. And so now we just need to evaluate it at these points. And so first we plug in pi. So we'll have negative cosine pi minus sine pi minus negative cosine negative pi/2. So we're plugging now in the lower limit of integration minus sine of negative pi/2. Okay, and the tricky part for this is probably just knowing how to evaluate all these. And so the integral of negative cosine pi, sorry, the cosine pi is -1 and sine pi is 0. Cosine negative pi/2 is 0. And sine of negative pi/2 is -1. And so this is what we have here. And so this is equal to 1. It's a lot of negatives. 1 minus 1. This is equal to 1. And so the answer is 0. Next question, a particle moves along a line with acceleration 3 minus t. Okay, so we're given the acceleration. We know that's the second derivative. So the second derivative is equal to 3 minus t. And we're given two initial conditions. So the first is that the initial velocity is 1. And the second is that the initial position is 0. Okay, so that's our differential equations with initial conditions. So to find the position function, we just need to integrate twice using this information. So first we need to find the velocity, which is the first derivative. And so we're going to integrate the acceleration. So that's the integral of 3 minus t dt, which is equal to 3t minus 1/2 t squared plus c. And then c here is going to equal 1. C is equal to 1 because when we plug in t equals 0, we should be getting 1, right? And so that means that the velocity function is 3t minus 1/2 t squared plus 1. Now to find the position, we just integrate the velocity. So that's the integral of 3t minus 1/2 t squared plus 1 dt. And if we integrate that, we have 3/2 t squared minus 1/6 t cubed plus t plus c. Now c should equal 5 because when we plug in t equals 0, we should get 5. And so the final answer is going to be 3/2 t squared minus 1/6 t cubed plus t plus 5. Okay, then the last question is just finding the position at t equals 2. So we just need to plug in 2. And so that's 3/2 times 4 minus 1/6 times 8 plus 2 plus 5. And so this equals 6 minus 4/3 plus 7, which is 35/3.